Fuel cells are fascinating devices that convert chemical energy directly into electrical energy through electrochemical reactions. At their core, fuel cells utilize a fuel, typically hydrogen, and an oxidant, often oxygen from the air, to generate electricity, water, and heat. This process is not only efficient, but also environmentally friendly, making fuel cells an appealing alternative to traditional combustion engines. To understand how fuel cells work, it's essential to grasp the concept of a redox reaction, which is short for reduction-oxidation reaction. In a hydrogen-oxygen fuel cell, hydrogen serves as the fuel and undergoes oxidation, while oxygen is reduced. The process begins when hydrogen gas is introduced to the anode of the fuel cell. Here, hydrogen molecules are split into protons and electrons through a catalytic reaction, often facilitated by a platinum catalyst. The protons, which are positively charged, pass through a proton exchange membrane to the cathode side of the cell. Meanwhile, the electrons, which cannot pass through the membrane, are forced to travel through an external circuit, generating an electric current that can be harnessed to power electric devices or vehicles. Once the protons reach the cathode, they encounter oxygen, which has been drawn from the air. The oxygen molecules combine with the incoming protons and the electrons that have traveled through the external circuit. This combination results in the formation of water and heat as byproducts. The overall reaction can be summarized as hydrogen and oxygen reacting to produce water and electricity. This reaction is highly efficient, with fuel cells achieving efficiencies of up to 60% or more, significantly higher than the typical efficiency of internal combustion engines, which usually operate at around 20 to 30%. The implications of hydrogen-oxygen fuel cells are particularly exciting in the context of transportation. Vehicles powered by fuel cells offer a clean alternative to fossil fuel-powered cars. Since the only byproduct of the fuel cell reaction is water, there are no harmful emissions such as carbon dioxide or nitrogen oxides, which are prevalent in conventional vehicles. This characteristic positions fuel cell technology as a key player in the transition to sustainable transportation, especially in urban areas where air quality is a significant concern. Moreover, hydrogen fuel can be produced from various sources, including water through electrolysis, natural gas, or biomass. This versatility means that hydrogen can be generated using renewable energy sources, further reducing the carbon footprint associated with fuel production. For example, using solar or wind energy to produce hydrogen through electrolysis can lead to a truly green energy cycle, where the electricity used to create the hydrogen is renewable, and the hydrogen itself can then be used to power vehicles without releasing greenhouse gases. In addition to their environmental benefits, hydrogen-oxygen fuel cells can also provide advantages in terms of range and refueling times. Unlike battery electric vehicles, which can take hours to recharge, hydrogen fuel cell vehicles can be refueled in a matter of minutes at hydrogen refueling stations. This rapid refueling capability addresses one of the significant barriers to the widespread adoption of electric vehicles, which is the time it takes to recharge batteries. Furthermore, fuel cells can deliver consistent power output, making them suitable for various applications, from powering cars to buses and even larger vehicles like trucks and trains. As technology advances and infrastructure for hydrogen production and distribution expands, we could see a significant shift in how we approach transportation, with fuel cells playing a central role in creating a cleaner, more sustainable future. In summary, fuel cells are remarkable devices that harness the power of hydrogen and oxygen through redox reactions to produce electrical energy efficiently and cleanly. Their potential applications in vehicles represent a promising avenue for reducing emissions and promoting sustainable energy practices. As we continue to innovate and invest in this technology, the dream of a hydrogen-powered future may soon become a reality, transforming the way we think about energy and transportation.